In this video, I'm going to go through a few examples where I use Table 4. This is a table that's at the end of Chapter 5, the chapter on the inductive generalization, and some of you may not need this video. The table's pretty straightforward once you get the hang of it, but for some of you it'll be useful to watch me go through this. So let's begin with this problem here. So this is the kind of thing that you use the table for. So let's say that I've selected 250 marbles from a jar and 175 of the marbles are red. So the first thing I need to do is figure out what the observed relative frequency is. That is, what percentage of red marbles do I have in front of me now that I've selected these 250. So to get that percentage, so the observed relative frequency is 0.7. Okay, now what's the percentage of red marbles in the jar itself? Now this is when we look at the table. So we begin, or first thing we need, this color here, is to figure out what our sample size is. So we selected 250 marbles from the jar. So the first thing we look at when we come to the table is this column here. And we see we've got 250, so we want to focus, once we've identified our sample size, we're just going to focus on this row of the table. And what we want to know in particular, probably the most important value here, is this one right here. The size of our interval is going to be 12%. So to use that information, we come back down here, we take our observed relative frequency and create an interval that's 12% wide that has 0.7 in the center. So we're going to subtract 6%, half of our interval, from 0.7. That gives us 0.64. And we're going to add 6% to 0.7. That's going to give us okay, so the percentage of red marbles in the jar is, I should insert the word between here, between 64% and 76%. We don't know exactly where it is, but we're pretty sure. This actually is only an estimation. We're 95% sure that the true percentage of red marbles in the jar, there of course is some true percentage, is somewhere between these two values. Could be anywhere between them. All right. Next problem. 500 marbles are selected from a jar. 200 are red, and the rest are non-red. So the observed relative frequency of red marbles is 0.4. The observed relative frequency of non-red marbles, that's going to be 300 out of our 500. 0.6. Okay, now in this case, our sample size is 500. We selected 500 from the entire population. So we come up here, and now we are on this column, on this row, 500. So the size of our interval is going to be 0.8. So again, we come down here and use that interval along with the information that we have about the observed relative frequencies. So in the jar, the percentage of red marbles is most likely 0.36, and Okay, so again, what we did was took our observed relative frequency and created an interval that was, or that is, 8% wide, 0.08, 8% wide around that 0.04. We have 0.4 right in the middle, and so our interval is going to range from 36% to 44%. And we do the same thing for the non-red marbles. The percentage of non-red marbles in the jar is most likely between, what do we have here, 0.56, 56%, and 64%. Okay, a little messy, but that's what you got. Now, here's an argument that for which you need to use table 4 to complete the argument. So premise 1, 100 Drexel undergraduates are randomly selected, and they're asked about the desserts in the cafeteria. So 57% say that the desserts in the cafeteria are fabulous. So here's our sample size, this number here, and this is our observed relative frequency, 0.57. Okay, so we want to know, based on this information in the premises, what can we say about the entire population, all Drexel undergraduates? So again, we go back to table 4. Here our sample size is the 100. So we want this interval, 0.18. So we take that interval and put it around 0.57, so to speak. So that's going to be, let's see, 9% in one direction and 9% in the other direction. So there's a 95% chance that between, not enough room here, 48% and we got 66% of all Drexel undergraduates think that the desserts in the cafeteria are fabulous. All right, so good for Drexel. Okay, so that's all you need to know. It's pretty easy once you got it down. There's really nothing to it. So that, as they say, is that.